Hi all, here we're going to use identities to find all trig functions of an angle. We are going to look particularly at Pythagorean identities of sine squared theta plus cosine squared theta is equal to 1, or tangent squared theta plus 1 equals to secant squared theta, or 1 plus cotangent squared theta equals to cosecant squared theta. And quotient identities of tangent theta is equal to sine of theta divided by cosine of theta, and cotangent of theta equals to cosine of theta divided by sine of theta. Angle theta is an acute angle, and sine of theta is 6 out of 7, and we have to find cosine of theta using Pythagorean identity, which is sine squared theta plus cosine squared theta is equal to 1. And let's substitute what we know. We know that sine is 6 out of 7, and it's still squared, plus cosine squared theta, and it's equal to 1. So let's solve for cosine. 6 times 6 we have 36 out of 7 times 7, 49, plus cosine squared theta, and it's equal to 1. We are solving for cosine, so let's bring 36 out of 49 to the other side by subtracting it from both sides. And since it's a fraction, I like to subtract fractions in a line. This way it doesn't get confusing. So we get this adds up to 0. Cosine squared theta is equal to 1 minus 36 out of 49. We need a common denominator. Well, this is 1 out of 1. We can multiply top and bottom by 49. So we get cosine squared theta is equal to 49 minus 36 out of 49. Let me continue here. So cosine squared theta is equal to 49 minus 36 is 13 out of 49. Cosine squared theta is equal to 13 out of 49, but cosine, we need to do an inverse of the squaring, which would be a radical. Whatever you do to one side, you have to do the same thing to the other side. So square root on both sides. Square and square root are inverses, so they cancel out, and we get cosine theta is equal to square root of 13 out of square root of 49, and we get cosine theta is equal to radical 13 out of 7. And this is our solution for part A of this problem. So let's do the second part of the problem. And I'm just going to copy here the solution we got for cosine of theta, which is radical 13 out of 7. Now we have to find values of all the other trig functions using quotient identities. If you know what sine of theta is, you immediately know what cosecant of theta is. It's reciprocal of this fraction, which would be 7 out of 6. And reciprocal of cosine would be secant of theta. We flip the fraction and get 7 out of radical 13. So we just need to rationalize it. Radical 13 out of radical 13. And we get secant of theta is equal to 7 radical 13 out of 13. The last two trig functions are tangent of theta, and we have to use the quotient identity. So tangent of theta equals to sine of theta divided by cosine of theta. The other one is cotangent of theta, which is cosine theta divided by sine theta. So let's substitute and simplify. we get tangent of theta equals to sine of theta, which is 6 out of 7, divided by cosine of theta, which is radical 13 out of 7. In order to divide fractions, you keep the first one, 6 out of 7. You change division into multiplying and you flip the other fraction. So 7 out of radical 13. 7 and 7 will cancel. So tangent of theta is equal to 6 out of radical 13. Let's rationalize by multiplying top and bottom by square root of 13. And we get tangent theta equals to 6 radical 13 out of 13. So this is our solution for tangent, and let's do cotangent. So cotangent of theta is cosine, which we solved for earlier, which is equal to radical 13 divided by 7, divided by sine, which is 6 out of 7. Cotangent theta is equal to radical 13 out of 7 times 7 out of 6. 7 and 7 cancel, and we get cotangent theta is equal to radical 13 out of 6. And this is our solution for cotangent. That's all.